and read this fun announcement again. The following Zoom session is being recorded and will appear later today on my YouTube channel, Math with Mayo. There are 2 different classes that may be observing this session. Therefore, when you participate in the Zoom meeting, if you do not wish for your picture or your name to be made public, please leave the video off and use an alias name. If you have questions during the meeting but do not wish to speak, email me at bmayo@ybcc.edu and I'll respond as soon as I can. Okay, now, before we went to the break, we had a request for some more problems. Whoever that was, speak up and tell me what you want me to do.
Can you hear me?
I can.
Hello?
I can hear you.
Okay. I kind of caught the end of the last 55 number that you did, and the calculator I'm using is a little different. So I just wanted you to do another one so that I can make sure that I've got it right on the calculator.
Sure. Okay. Can you see the internet screen? I can't talk. Can you see the internet?
Yes.
Yeah. Okay. So let's put in, let's do, how about 42 factorial? Okay. And then equals. So this would be 1.4050061 times 10 to the 51st power. What's showing up on your screen when you do this?
Mine is 1.405006118 to the 51st power.
Okay, so basically your calculator is taking it out more places than the one online. Not to worry about it. If you were doing it, you'd just include all of those unless it said to do less than that. So you just put that whole thing in there. Okay.
Okay.
Do you want more examples or are you okay?
I think I'm okay.
Anybody else? More examples before we go back and we take a look at 14.2? All right, let's do that then. Okay. So we're moving on to section 14.2. And I can find my glasses. Ah, here they are. Okay. We're going to be talking about arithmetic sequences. Arithmetic sequences. Okay. And let's see here. We can get out of that. And let me just give you an example of an arithmetic sequence. When I teach Math 50 arithmetic, commonly one of my assignments is to tell students to do every other odd problem. Jamie, can you mute your microphone there?
Yes.
Do that? Okay, great, thanks. And then if you have a question, go ahead and turn it on. But that way we don't, somebody's pounding in the background and that's great. But okay, so an assignment that I will give to my students is I'll say, I want you to do every other odd problem, starting with problem number 1. So basically they would do 1, they would skip 3, they would do 5, they would skip 7, they would do 9, they would skip 11, they would do 13, they would skip 15, they would do 17, they would skip 19, 21, skip 23, 25, skip 27, 29, skip 31, 33, etc., etc., etc. Okay. This is an arithmetic sequence. And let's look at what's going on here. First of all, I want to talk about some notation. Okay. A general way of describing a term or a number in that sequence is to call it A sub n, as in A with a subscript of n. Okay. Now, specifically for this particular sequence, this would be A sub 1, A sub 2, A sub 3, A sub 4, A sub 5, 6, 7, A sub 8, whoops, A sub 9, etc. Okay, so the first term in the sequence is A sub 1, the fifth term in the sequence is A sub 5, the general term is A sub n. Any questions about that? All right, now notice to get from 1 to 5, what do? I add 4. To get from 5 to 9, what do? I add 4. To get from 9 to 13, I add 4, okay? That difference between the two numbers, which in each case is 4, is called the common difference, or D, and in this case, D equals 4. So the common difference between each term in the arithmetic sequence is 4. Now, in general, how can we find this? If we take any term in a sequence, let's take a sub 5, and we subtract the previous term. What is a sub 5 minus a sub 4? 17 minus 13 is 4. What is a sub 9 minus a sub 8? That's 33 minus 29, which is 4. So the common difference, and I'm gonna say this, a sub n minus a sub n minus 1 equals D. What is all this notation? Well, this is a term in the sequence. This would be the previous term in the sequence. So to find the common difference in an arithmetic sequence, you take a term in the sequence minus the previous term in the sequence. All right? Now, for this particular sequence, the first term is 1, right? In fact, what I want to do, I'm going to recopy this because I want to talk about some other things here. So this is going to be 1, 5, 9, 13, 17, 21, 25, etc. Okay. This is a sub 1, right? It's the first term in the sequence. Would you agree that I could call 5 a sub 1 plus 4? In other words, it's equal to the first term plus 4. Do you see where I'm getting at? Any questions there? All right. This term right here, 9, I could write that as the first term plus 2 times 4. Where am I getting the 2 times 4? Well, there's a 4 here and there's a 4 there, right? Still with me? The fourth term, I could write as a sub 1 plus 3 times 4, because it's 1 plus 4 plus 4 plus 4, or 3 times 4. Are you okay with that? I'm going to go back to this term, and instead of writing it the way that I did, I'm going to write it like this. A sub 1 plus 1 times 4. I just had a sub 1 plus 4, but I could put a 1 there, right? Now, notice a pattern. This is 1 times 4, 2 times 4, 3 times 4. Okay. Also, this is a sub 1, a sub 2, a sub 3, a sub 4, a sub 5, the terms in the sequence. Do you see that this number right here is 1 less than the subscript of the term? What am I getting at? I'm getting at a general formula for an arithmetic sequence. A given term in the sequence is equal to a sub 1 plus n minus 1 times d. D is the common difference, which in this case is 4. N is the subscript right here, but recall this is 1 less than that. This is 1 less than that. This is 1 less than that. Tell you what, let's go on to the next whiteboard screen and let's take this with us and let's go back and look at this thing again. So a sub n equals a sub 1 plus n minus 1 times d. All right. So we know that the first term is 1. In fact, we've got what? 1, 5, 9, 13, 17, 21, 25, etc. Okay. So a sub 2 would be a sub 1, which is 1, plus n minus 1, 2 minus 1 times d. What was the common difference? Do you remember?
4.
4.
Right, 4. So this is 1 plus what? 1 times 4, which is 1 plus 4, which is 5. So a sub 2 is 5. What about a sub 3? A sub 3 would be a sub 1, which is 1 plus n minus 1, 3 minus 1 times 4, which is 1 plus 2 times 4, 1 plus 8, which is 9. So a sub 3 is 9. Now, obviously, I could just keep adding 4 to get the next term, but I'm just trying to show you how this works. Let's say, for instance, you have this huge number of problems in front of you, and I said, I want you to do every other odd, but I want you to do 75 problems. So I want you to do 75 problems in this assignment, starting with problem number 1 and doing every other odd. So how do you know when to stop without actually counting them? Well, I want to know what the 75th term is going to be in this sequence. Okay? So let's come up here. A sub 75 would be a sub 1, which is 1, plus n minus 1, 75 minus 1, times d, which is the common difference. Yeah.
Excuse me.
Yeah.
I'm lost.
Okay. Where did I lose you?
Well, about halfway through the first part, I think you were going too fast, and I just kind of, my mind is not catching up.
Okay. Well, let's see if I can get you to see what I'm doing right now, and then if not, we'll go back. But okay. So we've got this formula, a sub n. This is some general term. We can choose n as any term in the sequence. Okay. It's equal to the first term plus n minus 1, this, whatever that number is, minus 1, so 1 less than that, times d, which is the common difference. And in this problem, d was equal to 4.
Okay.
So what I'm doing is, let me do this here. A sub n equals a sub 1 plus n minus 1 times d. We're trying to find the 75th term, okay? We know that the first term is 1. We know that the common difference is 4. That information was given.
Will they always give you what d equals?
No, sometimes you will figure it out.
Oh, okay.
But remember how you can figure it out? You take any term in the sequence minus the previous term.
Yeah.
Yeah, so yeah, it's going to be a case of where they're going to give you some of the information, and we're going to use that to find the rest of the information. Welcome to algebra, right? Yeah. Okay, so this is going to be 1 plus 75 minus 1 times 4. Before we go on, does anybody have any questions where I got any of those numbers from? I'm just plugging them into this formula. This is going to go right there. This is going to go right there. And this is going to go right there. So that's equal to 1 plus 74 times 4. And I'm going to go to my handy dandy calculator here. Let's see here. 74 times 4 is 296, so 297. So basically, if I'm doing an assignment, I'm doing 1, 5, 7, 9, let's see, 13, 15, 17, 21, 25, 29, etc. And I'm supposed to do 75 problems in this humongous assignment. I would stop with problem number 297. That would be the 75th term in that sequence. Now, back earlier, I talked about, well, you know, it would be easy to just, we could add 4, and we could add 4, and we could add 4, and we could add 4. But are you going to want to do that 75 times? No. So even though we can get the first few by just continuing to add the common difference, if we want to find out something way out there without finding all the ones in the middle, that's where this formula is going to come in handy. Okay. Now, this is for arithmetic sequences. Tomorrow we're going to look at geometric sequences, but let's not worry about tomorrow yet. There are also some problems in this assignment where you won't use this specific formula. They will give you a different formula and say, use that, okay? And what we're going to do right now, I'm going to give you some example problems. And the first ones, I'm going to give you a specific formula that they have listed. And in your WebAssign, if they do that to you, they'll give you the formula, okay? So for instance, this first one says, given that a sub n equals 4n minus 1, okay? So now we're not using that arithmetic sequence general formula that I gave you. We're using a sub n equals 4n minus 1. That's the formula. Write the first 5 terms of each sequence. So we want to find a sub 1, a sub 2, a sub 3, a sub 4, and a sub 5. And then find the specified term, which in this case is a sub 40. So using this formula, we're going to find the first 5 terms and the 40th term in this particular sequence. All right. So let's start with a sub 1. A sub 1 equals 4 times n, but what is n in this case?
40?
No, we're doing these.
Oh.
We're going to get there. We're going to do the first 5 and then we'll find the 40. A sub 1 would be the first term. So n is 1. Okay. Again, I'm looking for I'm going to find a sub 1, 2, 3, 4, 5, and then we'll find a sub 40. Okay.
Okay.
So a sub 1 is 4 times 1 minus 1, which is 4 minus 1, which is 3. So a sub 1 equals 3. Are you okay with that?
Yeah.
All right. A sub 2 is 4 times 2 minus 1. Again, I'm looking to this formula, which is 8 minus 1 or 7. A sub 3 is 4n minus 1, but n now is 3, which is 12 minus 1 or 11. A sub 4 is 4 times n, or 4 times 4 minus 1, 16 minus 1, which is 15. A sub 5 is 4 times n, or 4 times 5 minus 1, or 20 minus 1, which is 19. Now we'll find a sub 40. So a sub 40 is 4 times 40 minus 1, 160 minus 1, or 159. So I found the first 4 terms, excuse me, the first 5 terms in the sequence, and then the 40th term. Any questions about that particular problem? All right, are we good to go on to another example?
But can we do one of the other problems I did on the other?
Oh yes, we have 38 minutes left. I'm going to do 38 more minutes of examples. You bet.
Okay.
We'll get there. We'll get there. Patience. All right. Here is another problem. This one says a sub n equals n minus 1 over n. We are to find the first 5 terms. So a sub 1, a sub 2, a sub 3, a sub 4, a sub 5, and then it says to find the 12th term. Okay, and let's see here if I can get this to work a little better. All right, so a sub 1 is going to be 1 minus 1 over 1. What am I doing? Every place that n appears in the formula, I'm replacing it with the subscript 1. This would be equal to 0 over 1 or 0. You okay with that? A sub 2 is equal to 2 minus 1 over 2, which is 1 over 2, or just 1/2. A sub 3 is equal to 3 minus 1 over 3, which is 2/3. A sub 4 is equal to 4 minus 1 over 4, which is 3/4. A sub 5 is equal to 5 minus 1 over 5, which is 4/5. A sub 12 is equal to 12 minus 1 over 12, which is 11/12. So, are we okay with that one? All right, now we'll go ahead and we'll look at some problems involving that general formula for arithmetic sequences, okay? But there are some where they give you different formulas to use. All right. So this is what the direction says, or say, write the first 5 terms of each arithmetic sequence with the given properties and find the specified term. So again, write the first 5 terms of each arithmetic sequence with the given properties and find the specified term. Okay, we're told that the first term is 3. We're told that the common difference is 2. So we're going to use the formula a sub n equals a sub 1 plus the quantity n minus 1 times d. Why are we using that formula? Because it said arithmetic sequence. They told us the first term was 3. They told us the common difference was 2. We're to find the first 5 terms. We already have the first term, so we need to find the second, the third, the fourth, and the 5th term. And then it says also to find the 10th term. Okay? So it's an arithmetic sequence. They've given us the first term. They've given us the common difference. They want the first 5 terms and then the 10th term. Any questions yet? All right. Well, to find the first 5 terms, since I know the common difference, that's going to be quite easy. Each term is 2 more than the previous term. So 3 plus 2 is 5, plus 2 is 7, plus 2 is 9, plus 2 is 11. Okay. And I suppose I could find a sub 6, a sub 7, a sub 8, a sub 9. But what if they wanted a sub 3,412? Because that would not be an unfair question. My point is, we're going to use the formula to find this. Okay. So here I just added 2, added 2, added 2, added 2, the common difference. But for this last one, I'm going to use the formula, okay? So a sub 10 is equal to a sub 1. What's a sub 1 in this case?
3.
3 plus n minus 1. What's n in this case?
3.
No.
10.
10. Okay. You seeing that? What's D?
2.
2. So this is 3 plus 9 times 2, 3 plus 18, 21. So the first 5 terms, 3, 5, 7, 9, and 11, the 10th term is 21. Are we okay with this? Any questions on this problem? All right, let's go on to another problem. Let's see, where is it here? Again, we're going to find the first 5 terms of an arithmetic sequence with given properties and then a specified term. All right, we're told that the first term is 8 and the common difference is -5. So we're going to use a sub n equals a sub 1 plus the quantity n minus 1 times d. We're going to find the first 5 terms and the 25th term. Okay? Now, just like in the previous problem where I took a sub 1 plus the common difference to get a sub 2 plus the common difference to get a sub 3, et cetera, et cetera. Now in each case, what am I going to do? I'm going to add, careful, I'm going to add a -5. Isn't adding a -5 like subtracting 5? So 8 minus 5 is 3, minus 5 is -2, minus 5 is -7, minus 5 is -12. Okay, because here I'm adding -5, I'm adding -5, I'm adding -5, adding -5, which is just like subtracting 5. Are we okay with the first 5 terms?
Yeah.
All right, now let's go after the 25th term. So a sub 25 is a sub 1. What's a sub 1 in this problem?
8.
8.
8 plus n minus 1. What's n for this particular example?
25.
There we go. And what's d?
-5.
-5.
Right. So then this is 8 plus 24 times -5, which is 8 plus -120, which is -112, I believe. Let's see here. Let's check that out. 8 plus -120 is -112. The calculator does not fail me, at least not this time. So this is -112. Are we okay with this? Any questions about this? All right. This next problem says the first 3 terms of an arithmetic sequence are shown below. Okay, so a sub 1 is 1, a sub 2 is 4, and a sub 3 is 7. Find the specified term, and they want a sub 30. Okay, so we know it's an arithmetic sequence because they told us that. So we're going to use a sub n equals a sub 1 plus n minus 1 times d. Okay. They've given us not only the first term, but the first 3 terms. And they've asked us to find a sub 30. Okay. The formula over on the right side, to use that, we need a sub 1. Do we have a sub 1? Are we given a sub 1?
Yes, it would be the 1, right?
Right. Do we have D?
No.
How can we find D?
By minusing from the previous.
Minusing the previous. Okay. What's 7 minus 4?
3.
What's 4 minus 1?
3.
So if we take a term minus the previous term, we get 3, right?
Yes.
Okay, we now have all we need to find a sub 30. A sub 30 equals a sub 1, which is 1, plus n minus 1, which is 30 minus 1, times the common difference, which is 3. So all that's left is to do the arithmetic simplification. Any questions before we finish this problem? Any questions about where any of the numbers came from?
No.
All right, so this is 1 plus what? 29 times 3, which is 1 plus what? 87, which is 88. So a sub 30 is 88. Again, any questions? Okay.
I have a question.
Yes.
Somehow I got a different answer than you.
Oh.
So right on where it says 1 plus 29 times 3, I did 1 plus 29 is 30, and then times 3, and so I got an answer of 90.
Okay, here's the law that you broke. We won't arrest you, but the law you broke, order of operations, you do multiplication before addition.
Okay, yeah, I didn't know that.
Yeah.
Okay.
Okay, all right. Go and break the law no more. Okay. All right, any other questions before we go on? All right.
No.
New example. It says, write the first 5 terms of the arithmetic sequence with the following properties. Okay, so we're supposed to write the first 5 terms. And they tell us that the first term is 5 and the 5th term is 29. Okay, they told us it was an arithmetic sequence, so we're going to use a sub n equals a sub 1 plus the quantity n minus 1 times d. Okay, this problem is a little bit trickier. So again, they want the first 5 terms. They gave us the first term and the 5th term. They told us it was an arithmetic sequence, so we know to use this formula. All right? So here's what we're going to do. We're going to take what we know to find what we don't know. We know a sub 1. We don't know d. But if a sub 5 is 29, I can do the following. I can say a sub 5, let's see here, equals 29, right? Actually, I want to do that second. Give me just a minute here. Let's use the formula, okay? And we could say a sub 5 equals a sub 1, which is 5 plus 5 minus 1 times d. Okay, now I know that a sub 5 equals 29, but doesn't it also equal 5 plus 5 minus 1 times d? Which would be 5 plus 4d. My handwriting is atrocious. Does everybody see where I got that a sub 5 equals 5 plus 4d? But doesn't a sub 5 also equal 29? We were given that.
Yeah.
Well, if a sub 5 equals 5 plus 4d, but a sub 5 also equals 29, we can say that 5 plus 4d equals 29. We've got two different ways of describing a sub 5, so those two descriptions are also equal. Today is Tuesday. Today is hot. We could then say Tuesday is hot. A sub 5 equals 5 plus 4d. A sub 5 equals 29. So 5 plus 4d equals 29. Why do we care about this? Because now we can come back and solve for d by solving that equation, subtracting 5 from both sides. 4d equals 24. Divide both sides by 4. D equals 6. Well, if d equals 6, what's 5 plus 6? What's 11 plus 6? What's 17 plus 6? What's 23 plus 6? Bingo.
So you got it from using the first and the last one?
Yep. I got it from creating a situation that I could turn into an equation. I know the last term or fifth term is 29, but plugging what I do know in here, I know a sub 1 and I know n, which allows me to come up with that, and I can go on and solve for d. I know things got a little trickier. So if you fell asleep the last hour, you got to wake up because this is the trickier stuff. Okay. Any questions before I go on? All right. Another example. Write the first 5 terms of the arithmetic sequence with the following properties: a sub 1, a sub 2, a sub 3, a sub 4, a sub 5. They tell us that the first term is -4, and they tell us that the sixth term is -39. Okay, they want the first 5 terms, but they give us the first term and the sixth term. Again, they said it was an arithmetic sequence, so a sub n equals a sub 1 plus the quantity n minus 1 times d. Okay, I'm going to do the exact same thing I did in the previous problem. A sub 6 would be a sub 1, which is -4, plus 6 minus 1 times d, which is -4 plus 5d. So a sub 6 equals -4 plus 5d. But I also know a sub 6 equals -39. Therefore, this equals that. So our equation becomes.
So why do we put a sub 6 on the first one?
Because we're trying to come up with a sub 6 in terms of d.
Oh.
Because our goal is to have a sub 6 equals this and a sub 6 equals that. So now this equals that. Because we're not trying to find a sub 6. We know what it is. We're trying to find d. And by using this formula, when we use a sub 6, we can put everything in there except d. but then we've got this equals that, which leads to the equation. Can you wrap your head around that? So then we're going to add 4 to both sides. 5d equals negative 35. Divide both sides by 5. D equals negative 7. So the common difference is negative 7. Negative 4 plus negative 7 is negative 11. Negative 11 plus negative 7 is negative 18. Plus negative 7 is negative 25. Plus negative 7 is negative 32. Plus negative 7 is negative 39. So there's the first 5 terms. Today is Tuesday. Today is hot. Tuesday is hot. We've got to have 2 different ways of describing the same thing so that then we can set those 2 into an equation situation, which then allows us to find D. And once we find D, the rest of it falls in place.
So with problems like this, we're always gonna put the last one for the first.
I lost you there.
So with problems like this, we'll always put a sub 6 where it's at right now, so we can figure out the rest.
Yeah, well, you're gonna, if you're given a certain one like this, you can also plug it in, to find it. And what are you trying to find? You're trying to find D. So yeah, you'd use this because you weren't given these other ones in here. You'd use this to set up your equation. Okay. All right. One more idea, a little bit more of a stretch, but we're actually going to come back and do this same process ultimately. An arithmetic mean is like a middle value. So let's say I had 1 and 3, and I want to know the arithmetic mean between 1 and 3. What would the middle value be?
2.
2, right, okay. But what if I had 1 and 4, and I said, I wanted you to find 2 arithmetic means? What that means is that I want 2 numbers in the middle such that all the numbers are evenly spaced. So what would this be? What would the 2
and 3?
2 and 3, right? Okay. Now, what if I said, find the arithmetic mean between 8 and 16? What's halfway between 8 and 16?
12.
12. Okay, now, here's the scenario. It says, insert the given number of arithmetic means between the numbers. Okay? And it says 2 arithmetic means between 2 and 11. So my first term is 2. My last term is 11. But what is the subscript of the last term? Well, it says put in 2 arithmetic means. So that means there's going to be 2 of them in the middle. Okay, my first term is 2, my last term is 11. Since they want 2 arithmetic means, my first term is 2, my fourth term is 11. Do you see how I got that a sub 4 was 11?
Mm-hmm.
If it had asked for 3 arithmetic means, then I would have had a sub 1, a sub 2, a sub 3, a sub 4, and then 11 would have been a sub 5. I've got the first, I've got the last, and I've got how many means in the middle, okay? Now, this problem is just like the last 2 problems. We're going to use this formula. And we're going to say a sub 4 equals a sub 1 plus 4 minus 1 times d. A sub 4 equals 2 plus 3d. But we're also going to say a sub 4 equals 11. Therefore, 2 plus 3d equals 11. So the only thing that was different about this problem than the last one is they gave me the last term, but I didn't know what term in the sequence it was. So I had to figure out, well, we've got the first term, 2 arithmetic means. So that's 1, 2, 3. Oh, it's the fourth term. So now 2 plus 3d equals 11. Solve for d. 3d equals 9. Divide by 3, d equals 3. 2 plus 3 is 5, plus 3 is 8, plus 3 is 11. So the two arithmetic means between 2 and 11 are 5 and 8. How are we doing? Is everyone in shock? We good to go on?
Yes.
All right, we're gonna look at another example. By the way, this is as far as we're going in terms of types of problems. Suddenly everyone's like, oh, I can breathe again. Okay, this says, insert the given number of arithmetic means between the numbers. 4 arithmetic means between 10 and 20. Okay. Here, I'm going to say a sub 1 is 10 and a sub question mark is 20. Okay. Now, we're supposed to put 4 arithmetic means in there. So that's a sub 2, a sub 3, a sub 4, and a sub 5. So then what would a sub question mark be?
6.
Right. Okay. How do I know it was 6? Because I knew the first term, I had to put 4 arithmetic means in the middle. So now we're up to 5 terms. So the last term is a sub 6. So what are we going to do? We're going to use a sub n equals a sub 1 plus n minus 1 times d. A sub 6 equals a sub 1 plus 6 minus 1 times d, which is 10 plus 5d. But we also know that a sub 6 is 20. So 10 plus 5d equals 20. So again, I've used the same process in the last 4 or 5 problems. The only thing different about these last 2 was I had to figure out what the last term was by putting in the number of means that they requested. It asked for 4, so that means the last term was a sub 6. Solving for d, subtract 10 from both sides. Divide by 5, d equals 2. Oh, 10 plus 2 is 12, plus 2 is 14, plus 2 is 16, plus 2 is 18, plus 2 is 20. So there's the 4 arithmetic means.
So at the end, you just put what a sub 6 actually means at the end?
Say that first part again. I'm having a hard time understanding you. It's kind of muffled. Say it again.
A sub 6, at the end, you'll put what it actually means, like 20.
I'm still not.
And then you finish it off?
Well, yeah, I just checked to make sure that it worked. But what they asked for was the 4 means. In other words, the answer to the question was 12, 14, 16, and 18. It said, insert the given number of arithmetic means, blah, blah, blah. Okay. In fact, this is a common mistake students will make in reading the directions in WebAssign. For this problem, they'll put all 6 of them when all they're asking for is the 4 in the middle. Okay, so be sure to read the question carefully.
Okay, so we'll just put all
Just what?
the middle ones. We'll just put the middle ones.
Yeah, if that's what it's asking for.
And then on scratch paper, we'll do the rest.
Yes. Yes. So yeah, all in WebAssign, all you're going to do is you're going to enter. Here, tell you what. Let me take a minute here. We've got about 8 more minutes. Let's use them. Give me just a minute here to get into WebAssign. And okay. Let's see, this is section 14.2. Okay. All right, can you see WebAssign on your screen now?
Yeah.
Okay. Let's see here. Okay, take a look at number 8, for instance. It says, write the first 5 terms of the arithmetic sequence with the given properties and find the specified term. So here they want a sub 1, a sub 2, a sub 3, a sub 4, a sub 5, and a sub 10, because it's asking you for the first 5 plus the 10th one, right? So you're going to do the problem and then choose whichever one matches that. But and like here, it's kind of self-explanatory. It says, write the first 5 terms and the specified term. So you're going to fill in the boxes. You don't have to rewrite a sub 1 because it's already written there. Okay. Here, the first 3 terms of an arithmetic sequence are shown below. Find the specified term. So you're going to do all your work, but all you're going to put here is that actual 26th term. Does that make sense?
Yeah. Okay.
Here, insert 3 arithmetic means between 10 and 24. So they give you the first term, they give you the 5th term. They actually made this easy for you because they already showed that that's the first term and this would be the 5th term. Okay, so you don't even have to determine that. But this is a problem like the one we just did. So you'd say a sub 5 equals 24 and a sub 5 equals, here, let's do this problem. Let's see, what do we got? We've got a sub 1 is 10. And a sub 5 is 24. Does everybody see where I got that? I mean, it shows 3 empty boxes anyway, but. Okay, so now can you see my whiteboard?
Yeah.
So a sub 5 is a sub 1, which is 10, plus n minus 1, which is 5 minus 1 times d, which is 10 plus 4d. But a sub 5 is also 24. So 10 plus 4d equals 24. You following that? I hope that means yes. So then we'll subtract 10. So 4d equals, let's see. Oh, 4d equals 14. Divide by 4, d equals 7/2. Oh, So a sub 2 is going to be what? 10 plus 7/2. Recall yesterday I said that you don't want to use mixed numbers. So I'm going to have to take 10 plus 7/2 and write it as a improper fraction. Well, wouldn't that be 20/2 plus 7/2, which would be 27/2? You see where I'm getting that?
Yeah.
All right. What's the next one? It's 27 halves plus 7 halves, which would be 34 halves, but that's exactly 17.
Yeah.
34 halves plus 7 halves would be 41 halves, which doesn't come out exact. So let's go in here to WebAssign, and I'm going to have what? 27 halves. Okay. And then 17, and then 41 halves. Yay. Okay. Now, again, look at that 41 halves. It looks like 4.5, but it isn't. And if I put 4.5 in there, well, I'd probably write it just like that and it wouldn't know what to do with it.
I can't see that WebAssign.
You can't see the WebAssign?
No, I think you haven't shared it.
Oh, my bad. My bad. That's why I like you to tell me, because I sometimes forget to push the right buttons. Okay?
Yeah.
Now, 27 halves would be what? 13.5. So you could put 13.5 in there. But if it comes out to some repeating decimal or big long thing, don't go there. Okay?
Do we have to save any of the work we do on paper?
For your homework, you don't have, all I'm going to do is see the answers. Okay.
Yeah.
And while we're on it, and I'll mention this again, people will ask, here's what I want you to do when you take your tests. Okay. When you're taking your test, you're going to work out your problems and get the answer, okay, on paper. Then you're going to insert the answer on the test. On the test, there's a box where you can show your work. Don't do that because it takes forever to write it all in there. And if you do, you'll run out of time and you'll never finish the test. But what I want you to do is you're going to submit all your answers on WebAssign, okay? When you're all done with the test, if you want me to consider partial credit on the problems that you missed, if you email me the work that you did, so you could scan it or take a picture of it and send it to me. If you email me the work that you did that led to the wrong answer. Now listen very carefully, because half the time people don't do what I just said. What they do is they go in and they correct all their work, send me the right answers. I don't even look at it because that's not what I'm wanting. I'm wanting to see the work that you did that led to the wrong answers, so I can look at it and say, okay, they had this idea right, but they missed it here. I'm going to give them some partial credit for that, okay? But if you go in and correct them and send me the correct answers of the ones you missed, not even going to look at it, because that's not what I'm asking for. I'm not asking you to correct your mistakes and turn them in. I'm asking you to show me what your mistakes were. Okay?
Will you give feedback?
Sorry? Will I repeat that? Okay. When you take your tests, you're going to work all the things out on paper. You're going to just submit the answers in WebAssign, just like it is here in the homework, okay? Except you only get one try. When you're done with the test, let's say there were 20 questions and you missed number 3 and number 7, okay? If you want to scan number 3 and number 7, or take a picture with your phone, or however you want to do it, and send it to me right after you take your test, not 3 days later, okay? Not even a day later, but send me your work. I'll look at it to see if I can give you some partial credit, but don't correct your mistakes. That's not what I'm asking for. I want to see what it is you had right that ultimately went south, and so you got the wrong answer. Is that, you understand?
Yeah. I was just asking because my last teacher made us do every single question we ever did on homework or test, and we would run out of time. Okay,
let me ask you this. Who am I?
Ben.
I'm not your last teacher, am I? Okay.
No.
Mr. Ben, can you go back? Sorry for interrupting, but can you go back? Because I'm confused on the 17. Can you show me again how you got that?
Oh, yeah. Okay. So we determined that the common difference was 7/2, right? Oh.
Yeah.
Let's see, did I? Okay. So a sub 2 was 27/2. 27/2 plus 7/2 is 34/2, right?
Okay.
But what is 34 divided by 2? That's exactly 17.
Oh, okay.
Now, a question might be, well, what if I put in 34/2 instead? Would it mark it wrong? I don't know. Let's find out. Apparently not. Okay. You all right with that?
Okay. Yeah.
Okay. I'm going to stop the recording.